this session is about Java and security. Now, we from Oracle are very well aware of the fact that there's been a lot of noise about this in the press lately. And we would like an opportunity to talk to you about how we work in this area and what we're doing to improve the security of Java. Now, one of the things we have made, and this has been a plan that we've been working on for a very long time, is to hire a number of people to help us strengthen Java security. And one of them will be talking to you here today, so I'm not the speaker. I'd just like to thank you for being here today, and I hope that you will find this worthwhile. And with that, I'd like to introduce Milton Smith. Milton.
All right, thanks, Henrik. Okay. So good morning, and welcome to my session, Making the Future Secure with Java. So as Henrik said, the purpose of this session is to provide some background on what we do in security, our policy, and our program, and also to discuss some of our plans on how we're going to improve Java against new sort of attacks and things like that. So this right here, unlike a lot of sessions here going on at Java 1, is not a technical session per se, and we're not really going to discuss any vulnerabilities or that sort of thing. But I think at the conclusion, it's my hope that you'll get a better understanding for what we do in our group, and also some of our security plans for Java. Okay, so just a quick, for my own benefit, how many people are full-time security practitioners here? Okay, a few people. Oracle doesn't count, okay? Okay, how many with significant responsibilities in security? Okay, all right. So this right here is, you've probably seen a few of these at different presentations. Okay, so who am I? So I'm responsible for the Java security program, which is basically all the Java stuff except for EE. Which includes vision and features, and I help with the internal and external communications and things like that. My background, there's a lot of different expertise in security, and mine's programming. That's my background, and then I switched over to security some time ago, and it's been kind to me ever since. So I joined Oracle not too long ago from Yahoo, where I manage the security program for User Data Analytics Group. It's probably not as well known as email or IM or properties like that, but it's infinitely important because it's the knowledge of where the money and clicks come from. So we're going to talk about a number of things, and this is just a little agenda to kind of show you what we're going to cover. So not everybody has the same sort of skill set, so we're just going to do a little level setting about security in the industry, about risk and risk choices, and then do more, cover more on get away from industry and talk more about Oracle and what Oracle is doing for security and what we're doing in the Java group. And then finally, we'll talk about some of our security improvements that we'd like to make for Java, and then provide some actionable things that you can do as well as us. Okay, so I got these from the Java 1 site, and I noticed they're on posters around here and things, and to me it just it seemed pretty interesting. A lot of times we're deeply engaged in making Java and building Java better. We don't sometimes we're not as in touch with how people use it and some of these numbers. So I thought they were interesting. I figured I'd put them up there in case anybody has not seen them. But if you look at some of these numbers, 97% of enterprise desktops on Java, 1 billion downloads a year, 9 million developers worldwide, 3 billion devices. So to me, that means Java is highly relevant and pervasive. So a lot has changed. Java was introduced around 1995, and a lot has changed in the world since then. Around the 80s and 90s, data destruction was pretty popular. It was kind of cool to format your hard drive or do pranky little things like endless rebooting of your computer that you couldn't break out of and things like that, hacktivism. But I think that's kind of the key. The attacks were pranks, and for the purposes of demonstrating the technical prowess of attackers. But what we see today is really far different. Today there are a lot of worms and botnets that are popular. I actually was able to get some bot code on some of the dark channels and kind of pull it apart to see what it looks like. And it's amazingly sophisticated. The code that I happen to be looking at is a popular bot, and it includes basically a dynamic analysis which will scan computers looking for vulnerabilities, and then it contains several different payloads to inject itself when a vulnerability is found. And then also contains a cadre of commands. The one that I was looking at had about 50 different commands that it could check to unsecured IRC servers and await for commands from the bot herder. And some of the commands were pretty interesting. They ranged anywhere from, of course, format the hard drive to all sorts of other things, like look for QuickBook files, all sorts of things. And I think the main point to keep in mind here is that there's a shift. The shift is that instead of just destroying the target, well, now it's been realized that the target is valuable. It's nice to run quietly in the background. We like your computer, and we'll do things to it to evade your notice. It's valuable. The other thing that we've seen is state or terrorist-sponsored cyber warfare like Stuxnet and things like that. That is, of course, that's very different. We've seen intellectual property theft is a concern now. It used to be, 20 years ago that the borders were pretty solid. Everybody worked in the same place. The resources, data resources were, but nowadays, people work very distributed, and not only are the people distributed, but also the data is distributed. It can be in other countries, and unfortunately, not all countries enforce the rule of law the same. Another thing that's kind of interesting too is, so if we look at like a modern game like World of Warcraft, MMORPGs, they have a concept of virtual currency. And virtual currency actually has like an exchange rate like other currencies, and you can convert real dollars to so much virtual gold. But one of the things that's interesting about that I find is that the laws are very gray in some of these areas. So for instance, if you were to game the system and make lots of virtual gold, and somehow evade everybody's notice, it might be a breach of Blizzard's terms of service, but it's not necessarily against the law. So here you go. You have an opportunity where where money can be made, but it's not necessarily against the law. So it's an area where laws perhaps haven't caught up. So I think, today everybody's definitely more security conscious. Virtually every organization and user is concerned about security today. But one of the problems of security, or the challenges, is that strong versus poor security is difficult for users to evaluate. Today, if you're missing an enter or submit button on a form, it's plainly obvious. But if you have strong versus weak security, it's not so apparent to the user. It's harder to evaluate. In fact, it takes highly specialized skills and tools to evaluate two different products that provide the same features, right? Not easy to do for users. So what we're talking about here, we're going to kind of segue into risk a little bit, and risk versus rewards. And risk is really how we as humans function every day. We make risk choices. And so I devised a small test to test your risk awareness. It's pretty early, so bear with me. Okay, so when animals go to a watering hole, there may be other animals with big teeth present. Do you drink? Well, the answer is depends how thirsty you are, right? If you're not very thirsty, well, you might want to avoid the watering hole with all the big teeth animals. But if you're highly thirsty and haven't had a drink for a long time, well, maybe you're going to take the chance. Okay. So the second one, everyone that's been treated by a doctor has or will die. So the success rate is precisely 0. Do we continue to see doctors? Well, yes, of course we do. Doctors are still a benefit. Life is risky. So do we visit a doctor every day for a checkup? And the answer is no, right? So, I'm being humorous here to make a point, but we all make risk decisions every single day. And making risk choices and focusing our resources for the best possible impact is what we do. So just like the animals at the watering hole, our appetite for risk governs our behavior. And we use informal risk-based approaches. But sometimes not everybody makes the next step, right? Formalizing our thoughts about risk and how it governs our behavior. So risk as applied to software isn't necessarily a perfect process. We've learned a lot of things along the way about our risk areas, and just like medical technology, it improves over time. So it's still worth the doctor's visit, so to speak. So risk methodology helps drive security decisions. Fixing the wrong areas has no impact. Fixing low-risk areas provides little impact. The key is to focus on what matters. So what's so plainly obvious in our personal life also applies to our business life. So here is, to kind of bring things to a more concrete level, we're used to dealing with platforms here at Java, in the Java group, but an example that might be, that you can relate to would be web applications. And you make decisions about securing your web applications all the time. So some of the questions that you probably answer would be, for example, how important is the application to the business? Is it real important or is it not very important? If the application goes down, is it a high dollar loss or is it just an inconvenience? Are there compliance requirements to this system? So if something happens and you lose evidence, does somebody go to jail? Well, that's important, right? Or large fines. Also, internet-facing applications. What sort of interfaces does the web application provide? Are there web pages that are visible? Are there web data services? Things like that. So forward-facing things on the internet would be riskier, perhaps. Also, any sort of unauthenticated interfaces. So if you have an application that's visible on the web, and there are portions of your application that the internet at large does not have to authenticate to see, that means everybody can hit on those things anonymously. So that is a concern. And of course, those are just a small sampling of risk factors applied to the web application security space. And platforms definitely have different concerns, but the approach is very similar. So now that we've talked a little bit about the industry at large and level set it for a bit, now it's time to talk a little bit more about what we're doing here closer to home. So first of all, why is security important to Oracle? So for starters, Oracle produces Java technology, but Oracle also uses it as well. There's a lot of products here that use Java technology just like you guys use it. So basically, the product teams here have the same sort of demands and concerns that you guys do. And confidentiality and integrity, availability, very important to the Java ecosystem. So one of the things that helps us drive our decision process is policies. We have a number of different policies that are relevant. We're not going to talk about them all. We're not going to talk in depth about them, but we are going to take a look at a few because we've seen different questions in these areas and stuff. And one of those is communications. So we have several different ways that we communicate news to the communities. One of those is security alerts. You might have seen those before. And those are technical documents that provide information about impacted releases and risk, as well as remediation-based information. There's RSS feeds that you can subscribe to and things like that. Another is critical patch update advisories. So we're going to talk about the CPU process in a minute here, but basically it's how we do remediation for Java. In the CPU basically, so it's a binary that can be applied. The idea is to not include features and just include the remediation. So that way it keeps the risk of stability problems low. So another thing that comes up here is why don't we respond to published reports of alleged security vulnerabilities in Oracle products? So there's a lot of reasons. And so one of the things here too is you'll see in the slides, you'll see little policy links down there, so you can actually go out to Oracle's website and take a look at the real policy. So the bullets that I'm providing here are pretty high level. So one of the reasons why we don't respond to alleged vulnerabilities is that correcting or corroborating articles provides more information to attackers if it were a real vulnerability we were discussing. And we really just don't want to do that. Also, many times reports don't provide the required engineering details to really do an evaluation. A lot of things are purposely sensationalized and are really kind of light on what we would need from an engineering perspective to say that this thing really matches the alert that we just released or whatever, So technical details, preconditions, impact, remediation, mitigation details, everything is not there. Also, if we selectively communicated to some people and not other people, then what would happen is information about vulnerabilities would get out into the social media, and it would force customers to and the communities to have to go to social media in order to find out information about Oracle products, and that's just not a good way to operate. So what we do is, we are very precise in how we communicate. And when we communicate, it's actionable, and everybody receives it at the same time. So we have as you saw before, very precise modes of how we communicate this sort of information. So what we're looking at here, again, is a little bit more in-house. This is kind of you may have seen things like this before, software development lifecycle. This is not any particular cycle, it's just some sort of generic one that I put together. And it basically just shows, things go from a concept or a requirement stage all the way to delivery, which is on the second slide. But the idea here is that, like in the early stages of a project, we have security, okay? So we have security throughout the whole life cycle. And the idea of having it up front is that early on you can influence projects in a positive way. It's a lot easier to change an idea than it is to change a million lines of code, right? So get your concerns in and get them addressed up front, nudge and influence, that sort of thing. Also, we like to be engaged up front because certain things are high risk. We shouldn't need to spend the same amount of time that we spend for an incredibly risky project with a project that's not quite as risky. So, for example, an example of something, going back to the apps example, if you have an application on the internet with a lot of different interfaces, well, you're going to want to spend some time with that app. You're going to want to make sure all the input validation is being done properly and things like that. Versus if you have a application that is in the deepest, darkest corner of your data center and it's completely firewalled off, well, maybe that's a little bit different level of risk. Maybe it's not handling critical data. So maybe when teams make changes to that system, you don't need to focus on it quite as much. So those are the kind of things that you can get in the concept. And again, this is very summary level. There's a lot more detail than just a few bullets you can fit on a slide, but it's the idea. During analysis, you'd review the designs to see what engineering has come up with. Make sure that designs and architectural choices conform to security policies. During the coding process, peer review, things like that, manual assessments. Some static analysis actually can be done at that point too. And then into testing, we have security test cases that are also part of the functional tests. As we deliver new features and things like that, we have to create new test cases. One of the things that I'd like to kind of cover too is that we have a lot of custom tools that we need to use. A lot of times commercial analysis tools and things like that don't quite work on a platform like they would an application, because a lot of times we're coding to new things, but we'll talk about that more. And I think the other thing I'd like to say is that security is much more than just Milton Smith. There's a lot of folks that do security. There's a lot of people, a lot of engineers that have some top-notch security skills. We have GPS. Bruce here is a member of GPS, director, and does the security alerts group?
Yeah, Global Product Security.
Global Product Security, thank you. All right, and Eric Maurice from Security Assurance, is that correct? Yeah. Okay, so there's a lot of different folks and representing different areas, and we all come together to make Java a stronger product. The other thing is that we have ethical hacking teams that do periodic spot checks and things like that. We have SPOCs that are kind of like subject matter experts on security for their areas, as well as different sort of security training sessions and tech talks and things like that. So if we start looking at the remediation process, there's some different things there that are key. So we have adopted industry best practices for our scoring vulnerabilities, and we use the common vulnerability scoring system, which is available out there on the internet. You can see, but how it works is you go through a evaluation process, and at the end, the vulnerability gets a score, which is a real number that's positive, and the bigger the number, the more risk it is. So the process of evaluating and assigning the score is what we are, what I'm trying to coin as triage. And one of the things with triage is we really want triage to occur quickly. So the reason why triage needs to occur quickly is because until you've triaged a vulnerability, well, for one, you don't really know if it's just a spurious report or if it really is a vulnerability. But even beyond that, assuming that it was, you really don't know what the impact of that vulnerability is until it's been properly assessed. So a fast assessment is very important. And then after that assessment and the scoring take place, you can then determine and prioritize when the remediation should occur. And it is a very precise process. You just can't go from reported vulnerability to jamming it into the code, right? It doesn't work that way. There's a lot of impacts when changes are made, and they have to be vetted properly so as not to cause more damage. So the way that we handle the remediation is the critical patch updates, which are the binaries. For the Java platform group, they're done 3 times a year. It's not necessarily on the same cycle as Oracle, and we're looking at making some changes there for the future, perhaps. We also have emergency releases at times, depending on the risk and different factors. We may decide that an emergency release is appropriate. So this right here is kind of, it shows how the CPUs are laid out, basically every 4 months unless there's a little disruption with security alerts or things like that. And then there are some rules for Java CPUs. So Java CPUs are the main release for security vulnerabilities. That's how we remediate them, and we test them, and we make those binaries available to the communities. The other thing that's important to know is that there's different versions of Java out there that people are running, and we have to look at all the different releases, because sometimes a vulnerability in one release is also in another one, so we have to have a comprehensive approach that covers all families. Also, CPUs trigger the auto update process, so if you have the little icon on your tool tray to update Java, those would be, security fixes would be pushed out through that. So we do generally recommend that on. Dates for CPUs are published 12 months in advance. And security alerts are released as necessary, and they're very infrequent. And then there's the CPUs alternate between the regular releases, the non-CPUs, and so if you go to the next CPU, you would actually inherit some features from the previous non-CPU, but because of the way everything is staggered, if you implement the CPU or you install it, the non-CPU release would have been vetted for some time, so there's a lower risk of doing a security patch and then having some problems. That's the idea of that approach. And then we make those releases available on java.com and OTN. Okay, so I talked a little bit about different tools for securing platforms and applications. So typically an application is written for a particular use case, but really a platform has to encompass a lot of use cases. If you look at Java, it runs, it runs on devices, it runs, mobile devices, kiosks, servers, desktops. There's a lot of different use cases, and defending all those use cases is a little bit different than defending an app. We've had to develop a number of tools ourselves. If we take, if we just take a typical static analysis tool, a popular one, imagine when Java transitioned to the introduction of generics or something. So that was new things that we were experimenting with, making changes to the language, and running a static analysis tool through something that would use generics at the time would of course not work. It would break because the tool wouldn't necessarily understand generics. So here we're at the cutting edge developing new things, and so sometimes the current state of technology, we're one step ahead, so it doesn't work properly. That's not to say it doesn't in all cases, but it's something that we have to consider. And also due to the platform nature, we've developed tools that are specialized for what we do. And the purpose of communicating some of these differences is just to help you understand, how Java and securing Java might be a little different than securing an app. So one of the things that we're going to talk about now is some of the ongoing security improvements that we're making, that we've made, and some things that we have for the future. So one of the concerns nowadays is phishing attacks. There's a lot of people that get emails and from untrusted sources, and they click links in their email, and sometimes bad things happen. Why do people click links from untrusted sources? Well, I don't know, but they do. So I think the responsible thing really is that we need to be, what sort of measures can we implement to help defend against that? Keep our users safe and also make Java stronger. So one of the things that we're looking at is when the security baseline of the current JRE is out of date, we're investigating the possibility of putting some sort of pop-up or warning, which would prevent what we would call like a drive-by exploitation, where the user receives a phishing email, it contains some sort of malware link, and they would just click on the link and it would just automatically execute the Java virtual machine. And what we're talking about is getting rid of that, introducing a dialog that would prevent that from automatically executing. And those features would be configurable by the user. So it would default to a secured approach. So normally it would run properly, but if the JRE is old and out of date, then it would pop up that warning dialog if this sort of thing were to occur. The other thing that we're going to do is we're calling it, for a lack of a better name now, and we're calling it best used before date on JRE security. What is that really? So there are JREs that are deployed out there on standalone systems that perhaps don't have access to call back home and see what their security baseline is. And so what we're saying with those JREs is that the JRE will be aware of when it expires. So what do we mean by the JRE expiring? It's not really that it shuts down. It's just that it knows it knows that it's been sitting out there for 6 months or whatever that time is, but it knows that it's old and it hasn't been able to contact to find out what the newer version of Java is. So once it gets past that set point, it realizes it's old. It'll start to make some decisions a little bit differently. It will understand that it may be vulnerable, so it'll change its behavior a little bit. So an example of a behavior change, and we're not talking about just shutting down Java when it hits a certain date. What we're saying is once we've hit that date and we know we're old, maybe we'll pop up that warning dialog for a privileged sort of operation. Not for normal operations, but operations that would require some significant privileges. And once again, that's a feature that could be, I don't know what the interface for that will be yet. We're still working through that, but maybe, maybe a slider that could be adjusted that resets things to low or something like that.
How would that work on server side?
So I think, I'm just throwing out ideas here, so that's a good question. We don't have all those questions answered yet.
Well, it's not as important on the server side, right? I mean, this is more about helping on the client side, really.
Yeah, we're really, if you look at drive-by exploitation here, we're talking about, a virtual machine that would be on a desktop. Drive-by is typically a concern. Probably not going to check your email on a server or web surf, that sort of thing. But I think that we do want to look into, how this would apply to servers too.
Servers are obviously very important because the vulnerability spreads across more potential targets. But you can certainly put in alerts and things like that to alert the system that something's going on that looks suspicious. And if it's at a high enough level, then we could disable certain parts of the application. I think there's a lot that can be done there, and we'll be looking into things like that.
Okay, so some of the other things that we're thinking about is making it easier to disable Java. If there's, if you have a concern about Java running in your browser, we should just have a little on-off button or something like that. Something that you don't actually need to uninstall Java if you, if you just want to turn it off temporarily. So we're looking at something like that. How would that work? Maybe, on Windows it would be like a control panel option, or on OS X maybe system preferences. But I think once you get to wherever that spot is on that OS, it should be done in a very similar way. So it's easier to explain to folks. So one of the other things that I'll share too is so we're going to be starting to encourage users to uninstall older JREs. The first step is we've created an applet to help install some of these older versions. I mean, basically, Java would, for a while, it would put the new version out there, but not necessarily clean up the old one. And there were good reasons for that. And then I guess starting in 2007, JDK Update 10 started doing the sort of patch in place where it cleans up the old one and puts up the new one. But there's still some people that don't turn auto update on and things like that. So how do you clean all those users up? We've created this uninstaller applet. It's a first step. And actually, we're announcing that today. And Jeff Hoffman is going to talk more about that at 5:30, as well as Terry Yamamoto. And the Java User Experience team presents the latest UI updates. Long title, but so they'll be running that session, and they'll be kind of talking through some of those screens and how they look. I think, so the applet's a good step. It's a good step to help address this concern, but in the longer run, I think we want it more integrated with our installer, and so we're looking at that as a next step. So moving on to JRE security hardening. One of the things that we want to do is have a configurable IT policy. The IT policy would be what is allowed to run on the client for applets and JNLP. What are the named resources? What are the authoritative sources? Perhaps limiting what you can do by IP address. Wildcard supports, things like that. So those are some of the things that we're working through right now. And the idea is to really balance usability and security. And once again, this is another feature that can be turned off. So we're not strong-arming anybody into using the feature. but we're going to make it available to sites that want to be able to manage their IT policy for their organizations. Then we have we want to do more frequent security feeds, blacklists, and security baseline updates. So basically, we can blacklisting is really a last resort. So if there's a jar or something that we know contains malware, we can blacklist that. But we have to be very, very careful about blacklisting. Because, of course, if we blacklist something, now it's going to break somebody's stuff, right? So it has to be done thoughtfully. Okay, so we've discussed industry at large and a little bit about what we've been doing, some of the features we're thinking about, things we're thinking about, and now what are some of the things that you can do as well as us. So if you want to report vulnerabilities, you can report vulnerabilities to secalert_us@oracle.com, and you can see our policy there if you need more information. If you want to make new feature suggestions for security, you can report those there to the bugreport.sun.com/bugreport. And then also so that you have some sort of idea of when the CPU security patches will be available, we've kind of gathered those up here and put relevant links there. So there's some things that you can do for end users to help keep yourself secure. Keep your JRE up to date. Keeping your JRE up to date will ensure that you have all the latest security fixes on there. Also, make sure that you have your auto update on in case there is something that comes out, then you can get the latest patch. And then, of course, practice defense in depth, typical security practices, virus scanners, firewalls, whatever you think is appropriate for what you're doing. For developers, if you're developing on Java, well, try to support the most current JRE. That way your users can upgrade as well, right? Because nobody likes to try to run on a version of Java that the app is not certified on. So as a developer, if you keep your apps on the latest and greatest, then users can update. Signing applications, of course. Validating untrusted data. Do input and output validation. If you're taking data from untrusted sources, make sure that you don't get any surprises that you're not expecting. There's also a really good project out there, probably a lot of you already heard about it already, is the Open Web Application Security Project. They have a lot of good security resources and things that you can apply to what you're doing. Everything from coding practices and things that include Java to how to define test cases for different security things like authentication, authorization, stuff like that. There's also another session here on Wednesday, Secure Coding Guidelines for Java Programming. And that will be right here at the Hilton. So, yeah, so there's some stuff there you can do. And then we're also hiring. So security professionals, engineers. So you can come work with your heroes, and perhaps you can be a hero too. That's all I have. Concludes my session. Thank you.